First word in AI is model. Every model is a mathematical function. Takes in some inputs, which are in the form of numbers, and gives you some outputs, again in the form of numbers. So any problem can be phrased as this functional input-output relationship. Maybe let's say you've got a self-driving car. The inputs are everything it sees and its current acceleration and steering, and the outputs are where it should go, how it should turn, how it should speed up or slow down. That is a functional relationship. And the AI is this model, this function in the middle, which just maps between those two things. I could do many more examples, right? Another example would be a model, something like the recommendation algorithm in Netflix. That's this AI function, takes in your previous behavior, what you've watched, what you thumbs up, what you don't like, and it outputs maybe the score for each different movie, which it's considering to see what you might want to watch next. Any kind of input you have, any kind of output you want to be able to predict, you have this model in the middle and it learns the relationship between those two things. That's what people mean when they talk about models. One thing you always hear about comparing models is that this one is bigger than this one. What does that mean? Well, every mathematical equation, every model, is basically a series of calculations. And those calculations are, multiply by this number, add this number, anything that the AI learns that it needs to do to get from input to output. And a bigger model is just one with more of those calculations, more numbers to multiply by, essentially. And those are what we call the parameters. So when you hear that maybe GPT-5 is 100x bigger than GPT-4, not sure what the actual numbers are there, or you hear that Meta launched Llama 70B, 70 billion parameters, you know that means that's just how many numbers are contained in the input-output calculation that Llama does when it makes predictions. So more parameters essentially means a more complicated mathematical model. It means it can probably represent more complex relationships, which is why typically bigger models mean more intelligent models. Now we understand what AI models are, I want to tell you how do we train them. To start off with, an AI doesn't really understand anything. It's just a random collection of numbers, basically. And what we want to do is we want to make it learn to solve a useful problem, like give you useful text back or classify images. We give the input to the AI model. It makes a prediction about what it thinks the output should be. And to start with, these are terrible. It doesn't know anything. But every time we do that, we take its prediction and compare it with the correct prediction that we've got stored in this data set. This is called supervised learning because not only do we have the input, but we have a supervision of what it should give for the output. We compare what the model gave us with what we should have had. We compare the prediction with the label. And we use that to tell the model, okay, you should change things slightly in this way to make those things closer together. But you do that many, many millions, billions even times, so that each time it gets a bit better at predicting this general pattern between, say, your input request and your output response. When you're using ChatGPT, it's not training. It's not learning in real time from your interactions. Much like any other AI system, the self-driving car isn't learning as it drives on the road, unless you have that specialized setup. What's mostly happening is that the AI is locked up in a data center, not interacting with the real world, whilst you are making it make these predictions and updating the model. And then you freeze it, it doesn't change anymore, and you release it to the world. And that's what happens when you see OpenAI release GPT-5 or Anthropic release Claude Sonnet or whatever it is. You have finished this training phase and now you're giving it to the real world. To train an AI, you need to show it lots of examples. You don't want to have to wait for each example to finish before you show it the next one. You want to do this in parallel, side by side, simultaneously, so that ideally you can get the predictions and how to improve for 100 examples at once rather than have to wait and it take 100 times longer. So GPUs are specialized computers that are nowadays designed to help you do this kind of processing in parallel. There are many different ways to do AI, and one of those is machine learning. So machine learning is an approach to AI where you learn to do the task from data, right? Instead of following some heuristic or some particular algorithm, which is really smart, you show the AI system examples of the data, and it learns how to do the task, how to understand relationships in the data, how to make predictions from the data, from that data itself. So much like, showing a baby interacts with the real world, it learns to do tasks from the data which it gathers from that real world. So one of the most popular approaches to machine learning is to use what are known as neural networks. The whole idea with machine learning is that you have some mathematical way to take an input, like your request to ChatGPT, and turn it into a response like the response you get back from ChatGPT. The question is, what do you use to map between those two things? You could use any kind of mathematical function, but you want to use one that has enough flexibility to learn complex relationships. And this is what a neural network is. It is a mathematical function which, in theory, can learn the relationship between any two things, between, say, what a self-driving vehicle sees and how it should turn, the audio that it hears and how a voice agent should respond, how input images should be processed to give classifications. Any kind of relationship like that you want an AI model to be able to do, the neural network is something which in theory can learn any relationship. It gets much easier for them to learn these relationships as they get bigger. As you add more parameters, as you use bigger and bigger architectures for the neural networks. What is deep learning? You always hear deep learning next to machine learning and AI. Machine learning is an approach to AI where you learn to do this from the data, and deep learning is an approach to machine learning where you learn this from the data, but you use a neural network in the middle. You use this particular type of mathematical function which can, in theory, represent any kind of relationship. So when you're creating AI or putting AI to work, you have these two distinct different phases. One of them is the training phase and one of them is the production phase. Production you might also call inference or predictions or deployment, and training, that's the learning phase. At this point, it's not actually seeing the real world. It's not sending any responses back to users. It's just kind of in testing, right? Once you've got it trained, you would give it to your users. You would connect it to the internet or connect it to your application so that users can send requests to it. And this is where we've put it into deployment. This is the second mode. Here we've deployed it, it's being used for inference, it's being used to make predictions, and it's actually connected to the product. So you're hoping at this point it's good enough that the predictions really solve the problem for the user. So at any given point, you've got the latest model from a model provider like GPT-5 from OpenAI right now. But at the same time that model is in production, there's also another model in training. No doubt they're training GPT-6 already. They're just waiting for that to be good enough so they can release it and replace GPT-5, which is used in ChatGPT. LLM, this is a large language model. Simply means the model understands text and usually gives us back text. The AI systems that you interact with that we use most these days, like ChatGPT or Claude, they are all large language models. Some of the most powerful models that we use today are multimodal models. This means they understand different or multiple modalities, not just text, but also images, also files. They can process all of these different kind of things together, and somehow they mix their understanding of the inputs you give them. The latest hype in AI is Gen AI, right? And all this means, simple understanding, is it's AI that generates data like that it was trained on, generates images, generates text, instead of making, say, predictions. If you have a model which predicts, what the price of a certain real estate market is going to look like in a year from now, that's not generating more real estate pricing data. It's just giving you a prediction. So if you were to ask me a question, a hard question, I would have to sit and I'd think about it. I wouldn't respond with the first thing that comes to mind. And we've found ways to give AI this capability to make them more intelligent as well. And we call this reasoning. This is where, instead of just immediately generating text responses to answer your question, AI generate text responses which they keep to themselves as an internal monologue. It lets them think through the problem and reason about what the right answer should be before they then go into a different mode and give you a final output response. And we've seen it can make AI much more intelligent and provide much more better responses on tougher and tougher benchmarks. So reasoning is one of the big unlocks for AI. The big hype right now in AI is agents. And everybody I speak to who's in a leadership position is somewhat confused by everything they hear as to what are agents, what are assistants, what are co-pilots, what's the difference. The main thing about agents is that they do work in the background. The idea, when we talk about AI becoming more and more agentic, we mean that it can do more work for longer in the background. So you can imagine giving a task to an AI, it performs it overnight, or maybe over a week, rather than requiring your input in the next minute. So we've seen agentic systems. A good example would be OpenAI's deep research, right? It does about 30 minutes of work in an agentic fashion, goes and does some research online. Other examples would be OpenAI Codex, where it goes away and codes for a few hours and then comes back to you with the results. This is in contrast to assistants or co-pilots where you're kind of in the flow sequentially with them. You're working, step by step together, but you can't let it run off and do its own work for hours. The dream state would be that we have the drop-in remote worker type of AI, where you don't need to interact with it at all. It can just go and do its own work in the background, and that would be fully agentic AI.